So let's take a look at example 1. We have k of x equals negative 2 over 7 times the absolute value of x minus 5. So let's focus on going from left to right, one step at a time. Alright, so here we have a negative sign. So the negative sign is outside in front of the absolute value. So this one is going to be reflected across x-axis. Next, I'm going to focus on the fraction as, again, it's also outside in front of the absolute value. So since it's outside, it's going to be vertical. Since the numerator, the top, is less than the denominator, it means that the fraction is less than 1. This is going to be a vertical compress. Since it's vertical compress, I'm just going to write as what I see. So 2 over 7 from the problem. So vertical compress or any vertical dilation, you just write exactly how you see from the problem. And then the minus 5, it's inside the absolute value. So this one is going to be translate. Since it's inside behind the x, it's going to be translate. So translated right 5 units. So I had 3 transformation in an example, and I wrote out 3 transformation. Reflected across x-axis, vertical compressed by 2 over 7, and translated right 5 units. In this example, we have p of x equals 8 over 3, or 8/3, times the absolute value of x, and then plus 17. Alright, so starting from the left, I have 8 over 3. So the numerator, the top is greater than the denominator, the bottom, meaning the top is bigger than the bottom. So therefore, this fraction is bigger than 1. Since the fraction is outside and in the front, this is going to be classified as vertical. Since the fraction is more than 1, it will be classified as vertical stretched by, and since it's vertical, I'm just going to write exactly how I see the fraction in the problem or in the example. So vertical stretched by 8 over 3. And then the next transformation is the plus 17. Since it's behind and outside the absolute value, this is going to be translated up 17 units. So there were only 2 transformations in the given example. So I wrote out 2 transformations. Vertical stretched by 8 over 3, and then translated up 17 units. In this example, we have g of x equals the absolute value of negative 4 over 9 times x, and then minus 28. So here we have the negative sign. It's in front of x and it's inside. So this will be reflected across the y-axis. And then looking at the fraction, which is also inside and in front of x, since it's the numerator 4 that is less than the denominator, then that means that this fraction is less than 1. But keep in mind, it's inside and in front of the x. This is horizontal. So since the fraction is less than 1, that means that it's going to be a horizontal stretch. But again, since it's horizontal, I'm going to do reciprocal of the fraction. So instead of 4 over 9, I'm going to say 9 over 4. Last, we have the minus 28, which is behind the absolute value. So this is going to be translated down 28 units. So in this example, we had three transformations: the negative, the 4 over 9, and the minus 28. So for the negative, reflected across the y-axis because it's inside and in front of x. Horizontal stretch by 9 over 4 because the fraction is also inside and in front of x. And then translate down 28 units because the minus 28 is outside and behind. So in this example, we have h of x equal to the absolute value of 15 over 4 times x plus 3. So since the 15 over 4 is inside and we have another number with the x, you can see how we included a set of parentheses since the number is in front of x, similar to as if we were to do this with reflection and if there's a negative inside. So we want to keep this number intact in its original form. So that way you can identify the correct transformation with this plus 3. Alright, so the 15 over 4, since it's inside the absolute value lines and it's in front of x, so this will be classified as horizontal. Since the numerator is bigger than the denominator, this fraction is bigger than 1, so this will be horizontal compressed. By, since it's horizontal, I'm going to do the reciprocal of the fraction, so I'm going to write 4 over 15. Then we have one more transformation, the x plus 3. So since it's plus 3 with the x inside, this is going to be translated left 3 units. So, two transformation in the example, two written transformation. Horizontal compressed by 4 over 15, and then translated left 3 units. Alright, so in the previous example, you were given the function, given the equation, and you had to identify the transformation. Now here, you are given the transformation, and in return, you are to write the equation, write the function. So let's read out the transformation. Vertical compressed by 3 over 10, reflected across the y-axis, and then translated left 7 units for the absolute value of x. So I would write such as h of x equal. Now you can start in any particular order. So for example, if I say translate left 7 units, so you can write x plus 7. Now, what I'm going to do is check the other transformation. So this one says reflected across the y-axis. Reflected across the y. So that means that the negative sign is going to be the inside. So I have to include a set of parentheses with the negative in the front because the x has a number. And then since it's vertical compressed, that means that the fraction will be outside the absolute value. So I'm going to write vertical compressed by 3 over 10. So I'm going to put 3 over 10 outside. So my answer is h of x equals 3 over 10 times the absolute value of the negative of x plus 7. So let's review this example. Since there's a number with the x, and you also have a negative that's inside, so I have to include a set of parentheses so that I can put the negative in front while keeping this intact for plus 7. And then since it's vertical, the fraction will be outside the absolute value in the front. In this example, we are given 4 transformations. So the first one is horizontal compressed by 5/9. Second one is reflected across the x-axis. The third is translated down 8 units. And the last one is translated right 2 units for the absolute value of x. Now you can start in any order you like. Doesn't matter to me, as long as you write it in its proper place and its correct form. So I'm going to start with the translation. So let's look at the one that's going to be inside. So translated right 2 units. So that means that since it's translated right 2 units, it's going to be x minus 2. And then the other one, where it says down 8 units, so that's going to be on the outside of the absolute value. So since it's down, so minus 8. Now you can write the absolute value lines if you want to help determine its places. Alright, next. So reflected across the x-axis, that means it's a negative sign that's going to be outside the absolute value lines. And then last, the horizontal compressed by 5/9. So horizontal means that it's going to be inside. So since there's a number with the x already behind, I want to include a set of parentheses like this. So horizontal compressed by 5/9. So that means that the fraction will be in front of x, but I'm going to write the reciprocal. So I'm going to write 9/5. So my answer would be, and again I could use any letter, so maybe I use g of x equal. So equal to negative the absolute value of 9/5 times x minus 2 and then minus 8. So that's going to be my answer. And like I said, you can start with any transformation in any order, but sometimes I would try to work with the inner ones, so that way it'd be easier. But again, you can just put them in its rightful place as long as you know where the absolute value line is. And again, double check the transformation according to your equation.